In an earlier Creo Parametric video, I showed how to perform a global interference check. You go to the Analysis tab and then click Global Interference. Then we can hit the Preview button. And right now you can see that I have one interference in my assembly. That's because right now I'm performing this global interference check using the nominal values of the dimensions. Sometimes you want to perform a manual tolerance analysis by applying the worst case situations to the different dimensions in your model. And the way that you do that is by using what's called the dimension boundaries. First off, let's cancel out of here. And if you want to do anything with your tolerances, you need to display your tolerances on the screen. For example, I'm going to go to a hole feature that I'm going to put into the worst case. Let's find it in the model tree and then use the mini toolbar to click the Edit Dimensions command. And if I zoom in on this dimension, you can see that it's got 4 times a diameter of 3.5, and we don't see the tolerances for this particular dimension. If I click on the dimension, we're going to get its tab displayed. Right now, all the tolerance stuff is grayed out. Let's get out of here and turn on the display of your tolerances. You can go to File and then Options, and underneath Entity Display, they changed the options in Creo Parametric 6.0 where you have an additional choice. It used to be either show tolerances or do not show tolerances. Now they have this option here for show only ISO table driven tolerances, but I'm going to turn on my tolerance display. And that's a command that I use so often that I have added it to a couple of additional tabs. I have a common tab that you got starting in around Creo Parametric 4 or 5, where I've added the command there so I have it available in all different modes. I have my own personal commands tab as well. So again, make the interface work for you. Now when I go to the hole feature in the model tree and choose Edit Dimensions, you can see now we have tolerances in here. If I click on it, we have the ability to change the values of the tolerances and also the tolerance mode. Right now it's using plus minus. I could go to plus minus symmetric limits, make it a basic dimension or nominal. So let's take a look at how we can make our dimensions into their worst case situation. You can do this either in part mode or assembly mode. I'm going to hop over to the part for a second. Let's select this hole. And then from the mini toolbar, we can choose the Edit Dimensions. And again, we can see that right now it is plus 0.1 and minus 0.1. So worst case situation would be if the fastener was at the maximum condition and the hole was at the minimum condition. So in order to apply that to this particular feature, we can go to the Tolerance Analysis dropdown. And here's the Dimension Boundaries command. And here you can set all dimensions or set selected dimensions to the upper, middle, lower, or nominal values. Later on, I'll show you the Dimension Boundaries table command. And before I do that, let's take a look at the mass properties, because one thing that I want to point out is that applying the boundaries to the different dimensions is actually going to change the model geometry. So right now, this particular hole is at its nominal value of 3.5. Let's take a look at our mass properties. I'll choose Mass Properties, then let's click the Preview button. And I can see that the mass properties right now, the value is 1.9870836 out to a number of decimal places. So I'm just going to remember those last 3 decimal places, 836 over on the end. Let's get out of here. And now we will apply our dimension boundaries. And let's choose Set Selected. And instead of using the nominal value, I want to set it to the lower value for these particular holes. And I'll select it and then pick the dimension and then click Done. And to verify, now if I go to the Measure command and choose Diameter, this hole right now is at a diameter of 3.4. So again, it actually changes the geometry. Let's close out of here and do our mass properties check and hit the Preview button. And before, the last three digits were 836. Now we can see the last three digits are 332. So again, it actually changes the geometry in the model and actually changes the values of the dimensions. So let's click cancel out of here. If we want to set everything back to nominal, again, we go to the drop down from tolerance analysis and choose dimension boundaries. And we'll choose set all nominal and then done. And now once again, if I check my diameter of this particular hole, it's a value of 3.5. And if I go to my mass properties and hit the preview button, we're back to the last three digits being 836. Let's cancel out of here and go back to the assembly. And you can apply the different dimensions, the upper and lower bounds of your dimensions to the features in your model in the assembly for doing the analysis. Let's choose to do that. We'll go to the Analysis tab and then Tolerance Analysis, Dimension Boundaries. And again, for that particular hole, I want to set it to the lower value. Let's select the hole feature and then pick that dimension and then click Done out of there. To make this a worst case situation, I'm going to take this fastener and change it so that it is going to be at the upper bound of its dimensions. Let's go to Tolerance Analysis, Dimension Boundaries, and choose Upper, and then select this feature. And here we have, I have it exaggerated where we're going to have a upper tolerance of plus 0.2 on the dimension. So I'll choose that and then click Done. And now if we go to our interference check, before we only had one interference in the model. If I click the preview button, now you can see that we have a whole host of interferences between the fastener and the pan. And we can see that in here, the different situations where we're getting those interferences. Also getting interferences between the fastener and the standoff itself. So now that we've checked our worst case situation, let's cancel out of here. If you want to set everything back down to the nominal values, if you go to the tolerance analysis command and then dimension boundaries, and we'll choose set all to nominal and then click the done button, and then go back to global interference and hit the preview button, we're still seeing all those ones in there. So you have to be careful when you are applying the different dimension boundaries at the assembly level for feature level dimensions, because that set all to nominal does not work on the individual feature dimensions. I'd have to go back and let's cancel out of here and choose tolerance analysis, dimensional boundaries, set selected nominal, and find those features again. So let's select this one and set it to nominal, and also select the fastener and set this one to nominal, and then click done. And now if we go back to the global interference check and click preview, we're back to that first original interference between the receptacle and the PCB. So again, just be aware that the set all in nominal doesn't work on feature dimensions. So let's cancel out of here. Take a look at another option that you have. I'm going to go to the fastener in this particular situation. And if we go to the tolerance analysis, dimension boundaries, we have this other option here for dimension boundary table. And so in this particular case, let's select upper and for that diameter dimension, and then click done. And now when we go to the dimension boundaries command, we have dimension boundary table. We can save the current settings in our table, and you can set up different sets and apply that as a set. So for example, if I choose to save current, it asks me to enter in a name. Let's enter in max diameter. And that way now if I go to the show command, here we have the Pro Table Editor, and it shows us that the current value D1 dimension is set to upper, and it's got all the other dimensions set to nominal. And here's the one that we have called max diameter, where everything is set to upper. Then we can get out of here And let's set all back to nominal and click done. And that way, this will be back to the nominal value of the dimension. So one thing that you might want to consider doing if you're doing this in the assembly is to set up a dimension boundary table so that you can apply these different worst case situations that you want to check for global interference later on, because you can do that as well. You can go to dimension boundary and then apply for set selected, upper, lower, middle, and then save that as a dimension boundary table for doing your interference and clearance checks. I hope you enjoyed this video. For more information, please visit www.creowindshield.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button to be informed when new videos are uploaded. Thank you very much.